Hi, hello friends. Welcome to T Academy. Let's continue our Tamil Nadu Electricity Board previous AE paper exam. Okay, the question is here: which of the following relays has the capability of anticipating the possible major fault in transformer? So anticipating means expecting. The fault is going to be expecting. Okay, so it is the option is bulkous relay. So how is going to detect the bulkous relay? So actually in transformer, we assemble the transformer in the transformer tank. There we'll have a transformer winding like this, okay, which is on the core, okay, which is on the core like this. Now it is also having oil inside. So these are the oil. We can call it a transformer oil. When the overloading on the transformer winding happens, overloading means current will flow. Because of current will flow, there will be I square R losses. We can call it a copper losses. Because of this copper losses, there will be heat. Okay, as the heat is there, so because of that heat, the transformer oil is going to be heated. Generally, you know. Okay, because of that heating, the heat is transferred to the transformer oil surrounding the windings here like this. Now there will place a mechanism such a way that the heat will produce in the oil will causes some bubbles. So I repeat again, because of that heat given to the oil, so oil giving hydrogen bubbles like this, small bubbles, like we observed when in our homes when we cooking with the oil, when oil is heated up, it creates some bubbles, right? So such a kind of bubbles will happen inside the transformer because of overloading. As that overloading happens, it is going to lift the some small mechanism like this to upwards, just like our flushing mechanism. Okay, so this flushing mechanism will moving to upwards. Okay, so that the mechanism will give a alarm first. Okay, it's giving a signal that transformer is getting overheated. After that alarm, suddenly, if it exceeds a threshold value, then alarm will make given signal to the relay. So as the relay is there, so relay is going to be trip here. Okay, so only the relay which will anticipating, that means which is going to say a warning that because of that overloading or something fault happening inside the transformer winding, there will be heat. That heat is more means, okay, the heat is more means the transformer may get damages, like that it gives alarm. So bulkous relay is the only relay which will anticipate the fault, which will expect that the fault is going to come. Okay, other relays are there which works on the only fault. Okay, when the fault comes, other relays will work, such as overcurrent relay, differential relay, overflux relay. But bulkous relay is the only relay which will expect that fault is going to be occur, so that it will give a signal to the duty operator there. Okay, so that's the answer is bulkous relay is a transformer. And the next question here, okay, 76 question here, we can see here, the corona losses does not depends upon the corona loss. We will write the formula, basic formula here. The corona losses PL is equal to, it is 242.4. So in some text it will be 255 like that, but I am writing, just observe the formula, F plus 25 divided by delta into square root of R divided by D into V naught minus VPH whole square. So it's having units kilometer per phase per kilowatt. Now the corona losses not depending on, so it depends upon the delta values, atmosphere. Okay, and the conductor size means it's R, and line voltage here it is voltage, and height of the conductor, so it is independent of height of the conductor, but depends upon atmosphere, conductor size and line voltage. Okay, we'll move to next question. Here, consider the single line diagram shown in the figure below. If the base voltage is selected on the generator terminal as a 10 kV, so they given a generator voltage as a 10 kV given, what will be the base voltage on the transmission line? Now here there is a generator which will have a voltage of 10 kV, and there is a bus bar here. Let me take bus bar 1, and here is a bus bar 2, and there is a transformer which is a primary side is star, secondary side is delta, and here we have this transmission line. This entire section from here to here, it will be a transmission line, and this is a transformer here, delta to star, and this is a bus bar is there like this. Okay, now here what we need to find is, here the generator side the base voltage is given. How much? It is 10 kV, but what will be the base voltage here? Okay, now in the power system, transformer is the only place where the voltage is going to be changed. Okay, so here we'll find the base voltage. How we're going to find the base voltage? So VB2 is equal to primary base voltage VB1 into, now here next transformer is there, so because of transformer we'll take this rating of the transformer, so VT2 divided by VT1, or I can take it is from the number of turns. Okay, both will valid only. Now VB1 is how much? 10 kV base into, alright, VT2 is 132 kV divided by VT1 is 11 kV. Now so 11 1 11 12. Okay, now what is the base voltage here? It is going to be 10k into 12, so which is will be 120 kilovolts is the answer. So for this bit the 3 is the right answer. Okay, we'll move to the next question. Now the value of a matrix in x dash is equal to a into x for the system is described by y double dash plus 2y dot plus 3y is equal to 0. So if I write this equation in Laplace transformation, we can write as d square by d t into y of y plus dy by dt into 2 plus y into 3 is equal to 0. Again, if you take in Laplace transformation, I can write s square y of s plus 2 into s into y of s plus 3 into y of s is equal to 0. Now if you make all the y of s is a common here, now what you get? Y of s into s square plus 2s plus 3 is equal to 0. Okay, now here this is the only transfer function that is available. Okay, now we will check this answer. Okay, I don't know exactly what is the exact answer will be or procedure will be, but I'll give a shortcut here. Just take here si minus a in the transfer function and find the data of this. What is the s here? Yes, I means is a identity matrix, so s into 1 0 0 1 minus a value. So I know that I will check the answer directly with the fourth option. Why? Because I know the answer it is. So 0 1 and minus 3 minus 2. Now s 0 0 s, this matrix as it is. Now 0 1 minus 3 minus 2. So if I again find here, what will get here? So s minus 1 plus 3 plus 2. So this is what we'll get here, right? Now we will cross multiply. So cross multiply means here, sorry, here is going to be here it is s plus 2, sorry, s plus 2 here, right? Make a correction. So s into s plus 2 minus of minus means plus 3 is equal to 0, s square plus 2s plus 3 is equal to 0. Okay, so this is the matrix A. Okay, now we'll move to the next question here, and this is from control system itself. Now okay, see here, the Opulum transfer function of a unity feedback system g of s is equal to 50 divided by s square into s plus 2, the steady state error for unit acceleration input. Now ESS, steady state error, is inversely proportional to 1 by acceleration input. Now what is the k here? So k is equal to limit s tends to 0 s square into g of s. So acceleration input means the input is so parabola, right? Now that is equal to, so limit s tends to 0 s square, g of s means 50 divided by s square into s plus 2. So s square gets cancelled. If we substitute s is equal to 0 here, 50 divided by 0 plus 2, that is nothing but 25. Okay, we'll get K as 225. Okay, 25. Now ESS is equal to 1 by K into A. So K, sorry, is equal to 1 by 25 is equal to 0.04 is the right answer for this question. So the answer is 2, 0.04. Next question here. The negative feedback reduces. Negative feedback is going to reduce only the system gain, but it improves the system stability and it increases the bandwidth. How to remember this, sir? Remember here, the negative feedback reduces the system gain, and we know that the product of gain into bandwidth is nothing but a constant. So as we know that the gain will decreases means automatically bandwidth will increase. So the answer for this question is the system gain reduces by negative feedback. The next question here. The transfer function of the signal flow graph is shown in here and its transfer function we need to calculate here. Okay, the transfer function of the signal flow graph is shown here. Now first we will write the forward paths. Okay, so finally we will write the formula. First, forward path gain P1 is equal to, so entire 1. So forward path is this, like this, 1 G1 G4 here and this G2 and here is 1. So X5 and X2 all are nodes, so don't consider it. Okay, so first forward path is G1 G4, sorry, G1 G4 and here it is G2. Is there any other forward path here? Forward path means starting from the R to C, only one line, and here there is another path. Okay, let me correct here, this is this direction. Okay, now next forward path is G1 G4 G3. So where is G1 G4 G3? So G1 G4 will come like this, it will be jump like this and it will go. Okay, now next forward path is P2 is equal to G1 G4 G3. Okay, similar kind of question asked in GATE 2020, so that is today. Okay, what about L1? So loop, sir. Okay, first you'll write loop. So loop means it starts here, I can come back, but the G1 G4 H1 is not a loop. Okay, loop 1 I'll write G1 G4 and here it is H1. Is it loop? Yes, it is a loop only. Next one, loop 2 I'll write. What is the loop 2 here? Loop 2 is nothing but minus G1 G4 G2 H2. Similarly, what about the loop 3? Loop 3 is equal to minus G1 G4 G3 H2. Okay, so these are the 3 loops here. Now if you apply the Mason's gain formula, what it says is, so transfer function is equal to, it is the sum of the forward paths divided by 1 minus individual loops here. So non-touching loops are, I will consider only one here. So 1 minus L1 plus L2 plus L3. Okay, so add this P1 plus P2 and 1 minus L1 plus L2 plus L3, you will get the answer it as 2 is a right option for this question here. Okay, so hope you did it in the piece of paper and add all these values, you will get the same answer. Okay, so thank you friends, thanks for watching my video. If you like my video, please subscribe, share and comment. Have a nice day. Thank you.